Tonight's video is about the graphs of equations, and so by the end of it we're going to cover finding the intercepts on a graph, finding them from an equation, and then talking about symmetry with respect to the x-axis, y-axis, and origin. First we're going to talk about intercepts from the graph, which we should be familiar with. An intercept, keep in mind, is just wherever I cross the x-axis or the y-axis. So in our picture here, the x-intercept, one of them, occurs right here, right across the x-axis, and so that's in between -2 and -3. I have another x-intercept here that is just past -1, and I have an x-intercept over here that is just before +2. I only have one y-intercept in this case, right between -1 and -2 on the y-axis. We need to remember that an intercept is an ordered pair, and the x-intercept always has a y value of 0. The y-intercept always has an x value of 0. And so to find our x and y intercepts from an equation, all we're going to have to do is substitute 0 for y to find the x-intercept, and then substitute a 0 for x to find the y-intercept. So if I have this equation, y equals x squared minus 4, and I want to find the x-intercept, I'm going to replace y with 0. Once I've substituted 0 for y, I'm going to solve for x. So I need to add the 4 to both sides, which gives me 4 equals x squared. And then I need to take the square root, and the square root of 4 is 2, so my x-intercept becomes 2, 0. Similarly, for the y-intercept, I'm going to substitute a 0 for x. So here I've substituted 0 for x, and now simplifying I get y equals -4. So my y-intercept is 0, -4. So finding intercepts is just using zeros, substituting, and solving. Next we're going to discuss symmetry, and the first type of symmetry is symmetry with respect to the x-axis. And that says that I take every point x comma y, and if it's symmetric to the x-axis, it becomes x negative y. And so really what we've done is reflect across the x-axis. So I've taken this point, and to reflect it across the x-axis, I've changed the y to the opposite. Same thing here and here. This next picture is dealing with symmetry with respect to the y-axis. And so what we've done is reflect across the y-axis. So I've taken point xy, and to reflect it or make it symmetric with the y-axis, each point has been changed to the opposite of x and keeping y the same. So again, here's our original graph. I've reflected it across the x-axis so that it's symmetric, and I have xy becoming -xy. Our last picture deals with symmetry with respect to the origin, and that's reflecting across the origin. And so each point xy has become the opposite of each other. So here is my original point xy, and it's become -xy. -x, -y. Same thing with this point. Now I've given an equation and we want to test it for symmetry. Here's how we do it. With respect to the x-axis, we replace y with -y, and if we get a resulting equation that is equivalent, then that means it's symmetric with respect to the x-axis. Similarly, if I want to test the equation for symmetry with respect to the y-axis, I replace x by -x, and if I get an equivalent equation after simplification, then it's symmetric according to the y-axis. If I'm doing origin, I replace x with -x and y with -y. Simplify, if I get a equivalent equation, then it is symmetric with respect to the origin. So I want to test this equation, x equals y squared, for symmetry with respect to the x-axis, with respect to the y-axis, and then with respect to the origin. So if I'm going to test the graph of the equation for symmetry with respect to the x-axis, I'm going to replace the y with the opposite of y in the equation. So I've replaced y with negative y, and I want to see if, once I simplify, if I get an equivalent equation to what I started with. So I have x equals, and negative y to the second power is just y to the second power. And since I get what I started with, I know that this equation has symmetry with respect to the x-axis. And now I'm going to test it for symmetry along the y-axis. And to do that, I replace x with negative x. The resulting equation is negative x equals y squared, which is not equivalent to the original equation, so it's not symmetric with respect to the y-axis. And so lastly, I'm going to test it with respect to the origin. To test it for symmetry with respect to the origin, I have to replace x and y. X becomes negative x, y becomes negative y. Once I've replaced both variables, I need to simplify. And when I simplify, I get negative x equals y squared, which is not an equivalent equation. And so we can conclude that the graph is not symmetric with respect to the origin. And that concludes our video for tonight. See you tomorrow.